Yeah. Hi guys, thanks to Ivan for having us, and thank you for. I do apologise, we have no Italian, and what we do is very bad. And sorry for bringing the rain from London. What can we do? It follows us everywhere. So we're just going to give you a little taste of the games we've made over the last 2-3 years, since pretty much since lockdown, I guess. Ben's going to give you a little talk. Ben's our development director. I run around recruitment and outreach to the industry. We are hiring. Just a little bit about Climax. We've been around as an independent developer for 35 years. More recently, we were purchased by Keyword Studios. So our 150 developers are now part of 14,000 developers around the world. So I'll stop waffling, and Ben's going to show you what we've been up to. Excellent. Well, I'm going to hand you over to my colleague Ben Potton. He's going to talk all about porting our BAFTA award-winning game, Returnal.
So I'd like to give an overview of all our work on Returnal, but mainly concentrating today on getting Returnal running on PC. So to give you an overview of what went right, what went wrong, and some just general advice for releasing an Unreal Engine game. Yeah, the last person was much taller than me. Releasing a PC game on an Unreal Engine game on PC. So porting Returnal, or as I like to call it, why PC ports mostly suck. I don't know if there's any PC gamers in the audience, but yeah, they've not been good recently. So first of all, just a little bit about Climax, as Stuart said. So we were founded about 37 years ago. So we're based on the south coast of the UK, and that's our offices right there. Beautiful seafront view. And currently about 170 people, and about 155 of those are dev staff, and we're still looking to grow to maybe 200 by the end of this year. And as you mentioned, we were an independent studio for 35 years of our life, and we've recently been bought by Keywords, which has brought quite a load of benefits to us all. And we're known for console development, PC development, and we've worked with VR and AR and other kind of technologies. These are some of our games that we've worked on over the years. And we do full game development, co-development with other studios, and porting. So if you don't know about Returnal, I'll give you a brief overview of that as well. So it's a third-person roguelike science fiction shooter. The Housemarque, the Finnish developer, they were the main studio. It was published by Sony. It was one of the first PlayStation 5 titles. We were involved in both the original and the port as a co-dev role on the original. It was multi-award winning, lots and lots of awards, a couple of Game of the Year awards. It won a Game of the Year at the BAFTAs and 2 BAFTAs. And most importantly, it is rock hard. So if you like bullet hell, really tough games, you should definitely check it out. So how did it all start? Initially, it was a very cold trip to Helsinki for me, back in 2018, 2019, I think it was. And to begin with, we had a very small technical team that was implementing multiplayer for Housemarque. So we were just handling the cooperative gameplay and the other multiplayer elements. Over the next 2 years, that grew to a full cross-discipline team of about 50 people. And effectively, we were touching every part of the game. We were handling level design, everything from concept art to finished characters, VFX. We were doing coding across a whole range of systems. We basically owned 2 of the biomes, so we had full kind of creative control over that under Housemarque's guidance. So that kind of brings us to the decision to port. So why did we port it, or why was it ported? So obviously it was extremely successful on the PlayStation 5. And Sony have this new strategy where they bring their exclusive PS5 titles they publish over to PC, usually a couple of years after they've released on the PlayStation 5. And obviously, Climax were the obvious choice here. We've got a long history of porting titles, quality ports, and we knew the game completely backwards. We knew all the game systems, we knew how it should be played, we knew how the code worked, and we knew all the data pipelines. So how did it go? I guess that was the most important thing. These are some actual quotes from Metacritic, which I wrote down, very, very pleased with myself. This PS5 hit is a masterclass in porting a console game to PC. Why this sci-fi masterpiece works on PC? Loads of good feedback. The Metacritic is on par with the original, which tends to be unheard of on PC ports. So it was a huge success, and we're really pleased with how it turned out. But if you are a PC gamer, you're probably aware this isn't always the case. So here are some other quotes. I've taken the name of the games out of these, so I don't embarrass anyone. But yeah, PC ports generally don't go very well. So plagued with issues across the board, whether it's stuttering, frame rate instability, crashes, popping, or visual glitching. This is one of my favourite brutal ones. Last year was a disaster for PC games. Here's how things need to change. So how can we do better than this? Okay, so here's an overview of porting from PlayStation 5. It's an Unreal Engine game. It's easy, right? You just select your platform, click build, and it's all done. No, not quite. That would be a very boring talk if that was the case. So here are some of the problems you're going to run into. Firstly, Unreal Engine, as you probably know, comes with full source, which is brilliant for developers. They absolutely love that. But unfortunately, it means that developers like to modify the engine quite a lot. So Housemarque did this extensively. One of the things they put in was a complete custom global illumination system. And another one was their bespoke particle effect system, which is really cool to the way that Returnal looked and how it played as well. You can see an example of some of their test renders here and then how it's used in game. And while they did have PC versions of these systems so they could work with them in the editor, really it was designed for the PS5. It wasn't scalable at all. It didn't work on a range of hardware. It wasn't optimized. So we had a lot of work to try and port all this over. In addition, you've got your standard hardware issues when you're doing a port. So PlayStation 5 is a fixed platform. PCs vary massively. You can have very bad PCs, very good PCs. Obviously, Sony want the widest range of supported hardware as possible. The lower they can push that minimum spec, the more units they can sell. And the PlayStation 5 has some very clever technology in there. It has a extremely fast custom SSD architecture. It's got a custom 3D sound chip. It's got a OS that is totally dedicated to getting the best performance out of the hardware. So it's really hard to match the performance of it. And finally, and I say this as a PC gamer myself, they're a different breed. They play games differently to how console gamers play. So a console gamer, it's more about the whole experience, pick up the controller, sit in front of their television. With a PC gamer, it's quite often about showing off their rig, pushing their resolutions to something crazy, putting their new graphics card in and turning on ray tracing and all that kind of stuff. So they tend to play the game with a different mindset. So to begin with, you want to get the basics right when you're designing your PC spec. So you need to decide on your minimum and your maximum spec. So obviously CPU, GPU, memory, it's kind of obvious. But also your resolution. PC gamers have some crazy hardware, like ultra widescreen monitors, really stupid resolutions. What are you going to support? How low resolution are you going to support? Again, you've got your minimum frame rate and your maximum frame rate. So we decided for Returnal, it was an action game. You couldn't really play it below 60 frames a second, so that was what we based our minimum spec on. Also, you tend to find, if you're running a game at a very low frame rate or a very high frame rate, away from where it was designed, you might get physics issues or other kind of instabilities. So, yep, keyboard support, mouse support, all the standard stuff. And then it's deciding on what extra features you're going to bring to the PC version. So benchmark mode, lots of games have this, we put one in. And then you've got all of the NVIDIA or AMD specific tech you might want to put in, like ray tracing, DLSS, VRS, all the things that you see on the back of the box. And then some other considerations. So cross-play is quite important these days. Are you going to let PC gamers play with console gamers? Are you going to let Steam gamers play with Epic Store gamers? We didn't let the PlayStation 5 and PC gamers play together, but we did do kind of cross-store cross-play. And then DLC, obviously, it's normally expected you're going to include all the DLC in as well. So I wanted to talk a bit about shader caches. Because if you've ever been on the internet and there's a new PC game out and there's some issue with it, doesn't matter what it is, people are going to start complaining about shader caches. So I thought I'd give an overview to explain what they're talking about. So basically they're precompiled bundles of shader code that are used in the game. And why do we need them? So shaders are written in a high-level language and they need compiling for the hardware. Compiled shaders need to be created for every material in your game, and shaders are going to be unique to each graphics card model, unique to what settings you've got your game set to. Sometimes even driver versions can change the compiled shader code. So obviously that's many more permutations than you're going to get on a console. On a console you can just give the shaders compiled, ready to go. On the PC you have to compile them for each user who's playing your game. And if you don't cache them in some way, they're going to get compiled at runtime when you first see new material. And that's going to cause a stutter, and someone's going to go on Reddit and be very rude about your game. So if you're doing a PC Unreal 4 game or Unreal 5, it's quite similar. This is how you need to set them up. You have two stages, PSO data and PSO shader cache. PSO stands for Pipeline State Object. So that's basically an entire description of what your graphics hardware is doing and what shader it's using. During development, your tester will play the game, and when a new material is encountered, the state of the pipeline is stored in the pipeline state object data. So this is a database of every kind of material that they found. And then during release, your PSO cache is generated for the specific hardware that you're running the game on. This is usually done maybe at startup behind a loading screen or maybe a loading bar. The list of shaders will come from the PSO data that have been collected before. And obviously, if you miss a material, you're going to get a hitch. So how do you make them? Well, first thing, you turn on PSO caching and Unreal Engine. And then you're going to have to get your testers to encounter everything in the game. And when I say encounter, basically they have to experience every part of the level, every enemy, every combination of maybe weapon and situation. So they need to get very high coverage of all of your game content. And they need to do it with every graphical setting permutation that your game offers. So that's quite a lot of work they've got to do. And they need to redo it every time you change content. So this is where a lot of PC games fail. They're not keeping this data up to date. And you don't need to hit 100% coverage, but you need to aim really high. I think we hit 98% coverage, so 98% of the shaders were going to be pre-compiled before you got into the game. Also, you want to make sure you don't start the process too early, or you're going to get lots of old data, which is not relevant to the later content in your game. But you can't start it too late, because obviously you need to get really good coverage. And it probably goes without saying, procedurally generated content games, like a roguelike sci-fi shooter, for instance, makes this really difficult, because obviously no playthrough is the same. You've got to just repeatedly play through the game and try and get that coverage. But it's not all shader cache, despite what the internet says. There are loads of other things that can cause hitches on PC games. So here's just kind of one example of how better hardware can result in a worse experience for the player. So here's a really simplified frame graph. Here you can see the game's running, 60 frames per second, super smooth, loads of free time on the GPU, loads of free time on the CPU. That's going to be a really good experience for the player. Then maybe they go, oh, I want to buy a new graphics card. I've got a 4090, slot it in. I'm going to run it at 120 frames a second. So now you've got much less time to do everything in the game. Even though the GPU is still well within time, the CPU is overrunning the end of the frame. So in a situation like this, this is going to be a frame stutter. He's going to go on the internet and complain about you. And obviously it's never his fault, it's never his rig's fault, it's your fault. So I guess the takeaway is a faster frame rate means less time for everything else. And you're always going to be as slow as a bottleneck in your system, whether that's CPU or GPU or disk access. That's going to be the cause of your worst performance. And another thing which is kind of really important to think about, CPU load is normally much more spiky than GPU load. So you can go into an area of level that is maybe testing your GPU and it will go up and down. But CPU normally gets hit in big chunks. So let's say you go to a new area of the level, stuff loads in or unloads, you'll get a big frame hitch. And when you're running at 120 frames a second, you've not got a lot of time to handle all of that. Also, the interplay between all these systems is really hard to predict, so you're always going to get a few spikes. And any intermittent drop frames is going to be a micro stutter. So we kind of tackled this by taking each system in turn, optimizing it as best we could. There was a lot of issues with loading assets and unloading assets, so we used compression, those kind of tricks to try and get those little CPU spikes right down. So other hardware considerations, I kind of touched on it before, but the PlayStation has an ultra-fast SSD. It's much faster architecture than is possible on the PC. And the original Returnal used this massively for streaming, for example, streaming audio in, streaming parts of level. So this is a source of micro stutters. And obviously the controller, the PlayStation 5 controller is excellent. We had haptic feedback really heavily tied into the gameplay, which we then had to try and reproduce on the PC. And obviously it has the integrated speaker and touchpad, which you can't really do on the PC. So when it comes to other general development work, user interface support was a massive one. We had a lot of work done on this. As I mentioned earlier, ultra widescreen support. This is one of the Returnal screens' first test on an ultra wide monitor, and it looks really awful. So we basically had to go through every bit of UI content in the game, reposition it, make sure it looks good in all kinds of resolutions and aspect ratios. Obviously, you've got the standard controller screens on the PC, which you don't have to worry about on a PlayStation 5. And the massive amount of settings that every PC gamer is going to want on their title. So in terms of additional features, obviously you have the platform provided tech from NVIDIA, AMD, and even Intel. So DLSS, Reflex, VSR, there's a long kind of list of them that you can implement. I think we implemented DLSS 3, VSR, Reflex, in fact all of those we implemented. Now these are great because the libraries are made by the card manufacturers for you, and they can offer absolutely massive performance and quality improvements, particularly DLSS 3, it's amazing. But there's always a downside, so they don't work out of the box quite often. They're usually created for a specific version of Unreal Engine, normally 0.5 of a version after the one that you're developing with. And also visual issues are extremely common with these, and also render crashes are very common. So NVIDIA don't really know what games are doing. They make the tech, they stick it out there, and then you run your game and you see what goes wrong. So there's a lot of back and forth trying to fix issues. Also, we have the benchmark mode, which we added. So we took an approach where we built bespoke level content for this, because we really wanted it to be as representative as a real game play as possible. So we didn't want just a cutscene playing animations. We also provided extensive statistics about how the game was performing on CPU and GPU. We had dummy AI, so all of the creatures in the cutscene were running full kind of AI code, but in a reproducible manner, so you could test actual CPU usage and GPU. But it still can't recreate every aspect of real gameplay. But we think we did a pretty good job with this. So here's a quick overview of the benchmark results screen, so you can see the level of detail that we gave people. Obviously, a breakdown of CPU load, GPU load, where your bottleneck is, and estimation of what changing various settings will do to the game. So this went down extremely well. Cool. And just a few extra additional features that you need to think about. Obviously, Epic Store and Steam Store. There's some kind of implementation you need to do on those. This is quite an interesting one. Epic networking and Steam networking, particularly if you're doing cross-play. So the way we did this was by using Epic Online Services, which is brilliant. It's free. It lets you do cross-play. It's seamless. The only thing, it really annoyed Steam game owners. I don't know, they just see something with Epic installing on their PC, they get very angry about it. We weren't expecting that. But you should still use it because it's really good. The other thing which is worth noting about this is the original used a lot of tricks with the PlayStation networking system to store stuff like the ghosts and other kind of gameplay features which you just couldn't recreate on the PC using Steam or Epic. So we had to work with Sony Online Technology Group, and they kind of made a custom backend for us as well. So quite often you can't do everything you need with just Epic or Steam networking. Of course, you've got achievements. You need to make sure they are implemented and match the PlayStation version. And as I mentioned earlier, all the controller support. How is it going to play on keyboard and mouse? Lots of PC gamers will want to play it on keyboard and mouse. Cool. So, as you saw originally, it went really well, but we still missed some things. There were still some negative reviews and some angry people, as always. So we still had some stutters for a small number of people. So mainly edge cases, possibly people with very high spec GPUs but low spec CPUs, other kind of weird things that we didn't test for. This is something that's worth knowing. On Unreal Engine 4 and Unreal Engine 5, ray tracing shaders don't get handled by the PSA cache. So some people were running it on their Uber rigs with ray tracing turned on, and they were seeing the stutters. So Unreal Engine 5 does have some real-time caching, so we ported that to Unreal Engine 4 and it helped, but there's still going to be a slight stutter there. This is what one was quite interesting because we could never recreate it, but some people had the shader precompile fail. Rather embarrassingly, Digital Foundry had this shader precompile fail while they were doing their review. But we had a really good relationship with them. They reached out to us before they put the review out. We could patch it. We put in a manual kind of recompilers and we put some extra checking in. And so it didn't affect the review at the end of the day, and it didn't affect any PC gamers. So that was a kind of plus. We didn't expect to have to fix PS5 bugs. You don't think it's part of your job, but they come up in development. The testers report them. The reviewers report them and get very angry if you haven't fixed them. So if you're doing a port, bear in mind you might have to fix someone else's problem. Yeah, this one was nasty. We had a couple of fatal error crashes out there. Again, we couldn't recreate them, but you know, if your game's out there being played by hundreds of thousands of people, there's going to be some cases like this. And in our case, it was to do with a particle system that Housemarque wrote, and we managed to track it down and fix it. But yeah, that was a bit of a downer for us. And this was a real surprise for us. So, as I said, PC gamers can play games differently. Some of them play games by having a frame rate graph on the screen. And even if you're sitting down and the experience is nice and smooth, if they've got this graph on the screen and they can see it going up and down, they get very angry. We just didn't expect people to play the game like that, but they do. So, as a brief overview, how much work is it to port a AAA PS5 title to PC? So it took us 2 years, and we had 30 people at peak. So here's a breakdown of the kind of team makeup. 40% of those were coders, as you'd probably expect, very technical. We had artists covering optimization, UI work. We had a big internal QA team, obviously testing and making the PSO cache. Also, we had a much larger external test team who aren't in these numbers. And then we've got a little bit of design working on, PC controls, maybe a bit of audio rework. And then the rest is taken up with production and other overheads. So overall, quite a lot of work, probably more than you'd expect for a simple port, but this is kind of what you need to do for a good PC port. So, key takeaways. Why do PC ports usually suck? First off, not enough testing. So your key issues aren't going to show up on your dev PCs. You're not going to get shader cache stutters because you're playing it every day. You've probably got quite standard hardware. You've not got crazy setups. So you need an awful lot of testing. You need it early, and you need to get them replaying the game to recreate the shader caches. So not thinking like a member of the PC master race. So you've got to really think ridiculous resolutions, high frame rates, super widescreen. I think one of my favorite bugs was someone was running it super widescreen monitor, and they had it vertical. And they were like, why does this not work? And my answer was, what the hell are you doing? But it came up. So this is really important, not putting good enough people on it. So a quality port is almost more technically challenging than doing the original game, because quite often you're in that situation. It's a bit like Scotty from Star Trek. It's not going to work. It'll never happen. You can never get this running on this, and you have to make it work. So you really have to have top-notch technical people. As I mentioned, not engaging with NVIDIA and AMD early enough. They are brilliant. They write all this tech. They will profile your game for you. They will track down bugs for you. They will help in every way they can because they want the game to look good on their hardware. So really engage with them as early as you can. And likewise, not engaging with reviewers early enough. So as I mentioned, working with Digital Foundry and reviewers like that really helped us get a quality product out. It meant they weren't just going to write an awful review. They were going to come back to us and say, is this right? And then we got a chance to address any issues they have before they write their review. And I guess most importantly of all, not spending enough time, effort and money. It really isn't a cheap endeavour to do a quality PC port, which is why so many of them basically perform quite badly. So I would just like to leave you with this quote as well, which came from Metacritic. So developer Climax Studios has hit it out of the park with this port, and that made us all really happy because basically that's what we're aiming for, and getting feedback like that really makes your job worthwhile. So thank you very much. I've got time for some questions. Yeah.
Yes.
Go.
First, thank you. Really deep level. In my company, we work with Unreal Engine, so I am not a coder, but I recognize some of those issues, not at this level, obviously.
So, I have a question, and the question is, when you were just working on the PS5 version of the game, you were like working on PCs that had the same specs of a PS5?
Yes.
Oh, okay.
Yes.
For everyone, even for the audio department or...
Yeah. So
okay.
we had a recommended spec that everyone at Housemarque and everyone at Climax was using. It was, I guess at the time, maybe I can't remember if it was a 2080 or 3080 at the time, but it would be like a high-end NVIDIA card, an i7, a very fast SSD to help match the PlayStation 5 as much as you could.
Okay.
For the testers and QA that you said, did you, since from what you said, you need very wide PC specs in the end to test it, super PC, did you use professional services that are managing this, or you did it through early community?
We took a range of approaches. So the first thing we did is we purposely gave developers what we called Frankenstein machines. So Normally everyone would have the same machine, but we said, okay, you've got an AMD, you've got a lot of memory, you've got slightly less memory, you've got a really weird monitor. So that was our first kind of line of defense. Yes, and then I guess internally we had a whole range of PCs. We had what we call potatoes, which are our absolute bottom spec, and then various kind of high spec ones. And then the real bulk of the coverage was external QA, and Sony provided that for us, and they had the money and the facilities to test it across a huge range of PCs.
Hi, I'm a graphics developer, and I have to say I really appreciate this kind of talk where you go in depth in technicality, and I think there should be more of these things like that. But as a indie development event, most of the people don't really are exposed to this kind of low-level stuff. So what's your take on this, and what kind of low-level knowledge do you think it would help these kind of studios?
Yeah. So my key takeaway is, if you're using Unreal Engine, even if it's not a port, if you're doing an original PC title, you need to get that PSO cache. You need to understand it and know how it can make your game awful for people. And it's a really easy thing to miss, because if you're playing it, as I said, on your dev PC, your shader cache is going to be up to date naturally because you're playing the game every day. But you give it to someone for the first time, and they're going to have a terrible experience. So it's really going to affect your initial reviews if you put it out on Steam and you're getting these hitches. I'm actually not sure if there's similar issues with Unity, possibly, but yeah, that's my key takeaway for indie developers.
Hi, I wanted to ask, I was wondering, I guess when you're doing a port, you need to be as close as possible as to the original.
Yep.
But how much leeway do you have to maybe change things if you have to work around technical issues? And also as a bonus question, which is, if you had to compare like the experience of doing a port to that of creating an original game. Yep. I mean, they're obviously different, but I was wondering if the porting is still interesting and challenging, maybe even if in a different way. Thank you.
That's a great question. I'll start with the. I'll probably start with that one actually. So in terms of what's more interesting, doing the original and doing the port. Obviously, we did both in this case. We had a big involvement in Returnal, and we did a big involvement in the port. So working on the original is much more creative, as you can imagine. So that it really kind of scratches that creative itch, the kind of prototyping, getting gameplay right, testing things out. So that's a positive of doing an original. But also it's really hard. I mean, making a AAA title, I'm sure you all know, making a game of any sorts is really hard. So you can get a lot of frustrations, you can get a lot of stuff not working, you can do a lot of iteration and reiteration, and you can have late nights as you're trying to get stuff working. So that's the real pain point of doing creative work. With a port, I think artists might find it slightly less satisfying. But for a coder, there's an awful lot of technical problems to solve. As I said, it's that Scotty mentality. You know, you go to a coder and you say, this can never be done, and it just gets that kind of thing going in their mind, like, how can I do this? So I think for coders particularly, it's really, really quite a satisfying thing to do. So there's benefits on both sides. And to go to your original question, which is, well, how much leeway can we take with the game? So it depends on the game. We like to make sure that it's only graphical changes, if possible, so no gameplay changes. There was none in Returnal. We kept the gameplay exactly the same. I think in some of our really challenging ports we've done stuff like slow down animation rates and other things, but we made sure the game tick and all the logic was exactly the same. So yeah, you don't want to make it easier because then, yeah, it really annoys the original console owners.
Very last question.
No.
3.
Hi. As a developer that is working with I think the biggest publisher possible in the world, which is Sony, how much are you scared about recommended and minimum requirements of your game? Because it tends to be the cutting line for a lot of players, and they build expectations on that.
So you recommended specs? Is that
recommended and minimum.
Yeah.
If maybe you are scared,
Yeah.
maybe the publisher are scared about that, and if yes, how much?
Moderately scared. So the way that we approached it, so we had two key things. One was any PC that was going to hit the minimum spec has to run at 60 frames a second. So that really helped guide us. And that also allowed us to keep it quite fluid, so that the more we optimized, the more effort we put in, the lower we could push that minimum spec. Secondly, and this is another thing that everyone can do as well, we used the Steam hardware survey to see kind of what was out there, what was a typical rig that most people were running, and then you can make a judgment call on that about where you want to aim.
Okay, so thank you a lot, Pin, thank you a lot, Stu, for everything, for all this wonderful info, and for being our sponsor. And so I switch in Italian now. Bene, si è conclusa, direi magnificamente, questa prima giornata di Svilupparty Intro e Bologna Game Farm si gioca. Buona serata a tutte e a tutti, e ci vediamo domattina alle 10 al TPO in via Camillo Casarini 17. Buona serata.